A confidence interval for the population mean is in the form of your point estimate plus or minus your margin of error. Just like the confidence interval for a population proportion, to determine the margin of error, we need to know the sampling distribution of the sample mean. Recall that the distribution of x bar is approximately normal if the population from which the sample is drawn is normal or the sample size is sufficiently large. How large does it have to be? Well, if you look here, again, we're on sample mean side. N needs to be greater than or equal to 30 to be approximately normal. If it's less than 30, it needs to be normally distributed without outliers. In addition, the distribution of x bar has the same mean as the parent population and the standard deviation equal to the parent population's standard deviation divided by the square root of the sample size. And that again is on our overview sheet right here. We have 6 properties of the t-distribution. This is when the population standard deviation, sigma, is not known and sample size n is less than 30. The t-distribution is different for different degrees of freedom. You can visually see that here. The t-distribution is centered at 0 and is symmetric about 0, just like the normal distribution. The area under the curve is 1. The area under the curve to the right of 0 equals the area under the curve to the left of 0, which equals 1/2. So to the left and to the right is each 1/2, just like the normal distribution. As t increases or decreases without bound, the graph approaches but never equals 0. So just like the normal distribution, these lines approach the horizontal but never cross and never touch. 5th property, the area in the tails of the t-distribution is a little greater than the area in the tails of the standard normal distribution because we're using s as an estimate of sigma, therefore introducing further variability into the t statistic. You can see the blue line is normal. Here the yellow line, it's a t-distribution. You can see in the tail is a little greater. And as the sample size n increases, so as n increases, the density curve of t gets closer to the standard normal density curve. This result occurs as the sample size increases. The values of s get closer to the value of sigma by the law of large numbers. So see the figure to the right, which shows a t-distribution for n equaling 5 and 15, along with the standard normal density curve. You can see as n is increasing, it's getting closer and closer to the normal curve, which is the blue line. So if we wanted to order for the most area in the tail of these 3, which one would have the most area in the tail? And look which one has the most area in the tail. You can see the yellows on top. So n equaling 5, t-distribution was first. Then the next would be your purple line. So n equaling 15, t-distribution, and then your normal distribution.